Welcome to ERDC Live. I am your host, Shelley Tingle with the U.S. Army Engineer Research and Development Center. Today we welcome Mr. David Hibner, Director of ERDC's Geospatial Research Laboratory and the Army Geospatial Center. In addition, Mr. Hibner serves as the Army's Geospatial Information Officer. After serving more than 30 years in the Army and retiring last year at the rank of Colonel, Mr. Hibner now leads these two premier geospatial technology organizations in the Department of Defense. GRL is the only dedicated geospatial R&D laboratory in the DoD. GRL's staff of more than 80 engineers, scientists, and support personnel plan and execute all phases of the technology development process, from basic research to field implementation and commercialization. GRL is a leader in providing accurate, relevant geospatial information, capabilities, and research for the warfighter, and is a critical component of ERDC's world-class R&D mission. Mr. Hibner, welcome and thank you for joining us today.
Thank you very much. It's good to be here. And with that introduction, I don't think I have much more to say, so I appreciate you covering all that.
Thank you so much for being here. And so we're going to jump right into the questions. But before I do, I want to remind our audience that you are also part of the conversation. And so if you want to ask Mr. Hibner a question, just put that right there in the comments, and we will get to those as soon as our interview concludes. So my first question for you, as you are the director of both GRL and AGC, tell us a little bit about your dual roles and these organizations' distinct yet comparable missions.
Yeah, thanks for that question. I think it's more than just having comparable missions. It's really about the essential relationship between the Army Geospatial Center and the Geospatial Research Lab. And when I try to explain that to people, I like to do it in the context of something that I call the life cycle of geospatial, which is sort of a utopian view of how I would like to see things working between AGC and GRL to provide this essential support to the Army. So if you kind of break the life cycle down into its components, it really comes down to these two organizations. Within the Army Geospatial Center, we've got two major directorates, the Systems and Acquisition Support Directorate, and we also have the Warfighter Support Directorate. And then, of course, the third leg of the Army Geospatial Center stool is really the Geospatial Research Lab. And so in this utopian life cycle that I like to describe, you've got the Geospatial Research Lab that's doing all the cutting edge research and development and science and technology to make sure we're delivering geospatial capabilities to our Army to make sure we can fight and win our nation's wars. And then they're transitioning those through PEOs and other customers to our Systems and Acquisition Support Directorate, who's acquiring and distributing those systems out to the Army. And once they're out in the Army, they're making sure those systems are updated, that they stay interoperable with Army systems as those systems get updated. And they also run a capability that we call the node. And the node is really sort of the interlocutor between the Geospatial Research Lab and the Systems Acquisition Support Directorate, because we use the node on Army to test new capabilities on Army systems. And we really challenge those new capabilities and try to break them inside the node on our systems so that we know when they go out to the field that they're going to function the way that they're supposed to function. And then we've got our Warfighter Support Directorate, who's directly supporting the soldiers who are using those systems and leveraging the capabilities that were developed and transitioned by GRL to Systems and Acquisition Support Directorate. And they're training soldiers on those systems and making sure they're maintaining their readiness levels, make sure that that equipment is operating the way that it's supposed to be operating. And really, I think most importantly is they're getting feedback from the field on how those systems are working and what future requirements are being discovered by soldiers who are leveraging those systems. And then from Warfighter Support, they take that information and they provide it to the Geospatial Research Lab, who ingests that important information about what's required in the future. And then that cycle repeats itself over time. And so at any given time, we have all kinds of capabilities that are somewhere in this life cycle of geospatial that is turning between GRL, Systems and Acquisition Support Directorate, and the Warfighter Support Directorate. And it involves a lot of people, and it's extremely essential to the Army that that life cycle function as well as it possibly can. And I appreciate you mentioned the third hat that I wear, because it's also really important to the things that GRL and AGC does for the Army. As the GIO, I'm responsible for the Geospatial Governance Board and the Army Geospatial Enterprise. A lot of people don't realize this, but the Geospatial Governance Board is actually co-led by engineers and intel. And at the 3-star level, that means that the co-chairs are our very own Commanding General of USACE, Lieutenant General Spellman, and the Army for the geospatial data standards and the system certifications inside the Army Geospatial Enterprise, keeping Army and geospatial regulations up to date, especially as they pertain to geospatial intelligence, and integrating that information across the Army staff, meeting Army data standards and ensuring interoperability with Army systems. And then at the national level is the GIO. I'm a member of the Geospatial Intelligence Committee, or the GEOCOM, and I'm also one of 2 Army representatives on the National System for Geospatial Intelligence Senior Management Committee, or the NSMC. And both those committees are sponsored by NGA, who is the National Functional Area Manager for Geospatial for the United States. And then finally, one of the things that I do as the GIO also is advancing Army geospatial capabilities through the Army staff. And a recent example of that is by publishing the headquarters DA execution order for Army 3D geospatial data strategy, where we really want to discover what is the potential for leveraging 3D geospatial data in the Army so that we can make sure we're developing capabilities that meet those requirements.
And so earlier when you talked about this life cycle, it's clearly important that you understand the soldier, the warfighter, and all of this. And you had a distinguished career as an Army officer, serving with and commanding troops at every level. How did research and development in the geospatial engineering community help you and your soldiers?
Yeah, that's a fantastic question. And I think that's one of the things that I can bring to the Geospatial Research Lab is a pretty long history with the Army in a variety of different units, combat units and USACE, and looking at how those technologies were used, but also how do I see those systems now based on the experience that I had while I was in the Army. So importantly, I think it's good to point out that while I was in the Army, the actual R&D was invisible to me. So I think that's good. I think that's the way it should be, because what that does is it defines the trust relationship we have between our research labs and the soldiers who those capabilities are fielded to. So to give you an example, like when I was in the 3rd Infantry Division, I spent a lot of time in an M113 in training and in combat. And, I didn't really want or need to know what research and development went into the 113, but what I needed to have was trust that that 113 was going to operate the way that it was designed to operate so that I could use it in combat, to lead soldiers in combat and to bring capability against an enemy force. So I think understanding that trust relationship is really important. And I think a lot of people do have that understanding inside of the ERDC, that, we have this trust obligation for the people that we're transitioning these capabilities to. But I saw these systems in a couple different contexts, in training and in combat, and then also in lower levels of system support, so kind of at the tactical level, but also at higher levels like the division, corps, and national levels. And geospatial is all about time and space. And I like to further define it as the effective convergence of time and space and combat capability together. I think that's really sort of the essence of geospatial information and geospatial intelligence coming together to provide a combat capability to our forces. And at the lower level, back when I was a lieutenant or a captain, we used systems called Terabase and Falcon View. These were pretty, at the time we thought they were great. They basically did simple terrain analysis and line of sight analysis and things like that. But looking back on them today, they were actually pretty rudimentary, but that's part of this evolution of technology that we're constantly pushing the edge on. And then we also, in the early days, we had something called Blue Force Tracker, which was really, again, a geospatially based system where inside our vehicles, we could see where each other were, where all the friendly forces were. We could send messages to each other, little text messages to each other, essentially. But we also, importantly, could see where we thought the enemy was, so that as we're maneuvering against the enemy, we could do that as effectively as possible. And then at the higher operational level, again, back in 2003, when I went to combat in Iraq, we were getting high resolution imagery and LiDAR data that we were using in our planning process for the invasion of Iraq. We were visualizing the common operating picture on a variety of different systems, but there was this evolution of capability that I witnessed from Iraq in 2003 to Afghanistan in 2011. In Iraq, after we started our attack, we basically left our computers behind, and everything was about just map-based planning and map-based terrain analysis. And because I was in a mechanized unit, we were moving over vast distances in short periods of time, we basically created map books, thick books of, map after map of the area we were going to fight in with acetate overlays. And on those overlays, we were doing all the things that the tools that we're developing today are doing for us, but we were doing it by hand back then. We're doing, maneuver combined obstacle overlays and combining that with Intel situational templates and keeping those on our maps and flipping through those maps as we were going through that system. And we also had a system called the Joint Surveillance and Target Attack Radar System, or JSTARS. And JSTARS was an airborne platform that would send down basically geospatial intelligence to units on the ground so that we knew what we were up against in terms of what they were seeing on the ground for enemy forces and obstacles. And then, fast forward to 2011, when I was in Afghanistan, we had much more mature systems. We had advanced operations centers with real-time tracking and live video feeds from all kinds of different sensors and airborne surveillance platforms. And we had a level of dedicated satellite support that was unimaginable in 2003. And I think what's really important is that process of improvement and capability evolution it's so essential to keeping that pushing the envelope of R&D and S&T for geospatial capabilities. And having seen that evolution before my very eyes, starting way back, basically 32 years ago to today, I think I have a good understanding of the trajectory that we've been on and where I think we need to go in the future to make sure we're delivering the best geospatial capabilities that we can to the Army.
And so you talked about your experience in Afghan and Iraq. How does that inspire you and drive you as the director of both GRL and AGC?
Yeah, I think about that every day. What that experience left me with was a deep appreciation for how essential our capabilities are to warfighting. It really is sort of life and death, and that might sound sort of dramatic, but it's really not. If you think about the essentiality of geospatial and geospatial intelligence to conducting warfighting operations, and the ability to do that effectively will save lives, but conversely, the inability to do that effectively will cost lives. And so I have this deep-seated appreciation for just how important it is. And, I kind of look back and I think to myself, will the next Captain Hibner, some company commander somewhere in the Army, have the geospatial capabilities that person, that he or she is required to fight and win? And that is really up to us to make sure we're delivering on those capabilities. And it's a great responsibility, and it's a tough one, but it's also a very worthwhile and rewarding one. And again, it's that, convergence of combat capability with time and space to overwhelm an enemy position or an enemy capability that we're responsible for ensuring we have the capability of doing. So thousands of military personnel will be relying on us to fight and win in the future. And that's really dependent on the effectiveness of what we develop, making sure that what we provide has overmatch compared to our adversaries, and that they have ease of use and accessibility so that we don't have soldiers struggling to use these systems, that they can use them effectively and in a timely manner. And I think what we do in R&D and S&T sets the conditions for future wars. So putting it in another way, we're fighting battles today in our labs inside ERDC so that soldiers can fight and win on the battlefields of the future. So we have to win these battles now in our labs so that our soldiers can win battles in the future. And again, I don't think that's a dramatization. I think that's reality. And when I look at what we're developing, I see it from the perspective of using those capabilities in combat. I can picture myself, either in a TOC or in a 113 or on the ground, trying to leverage these systems effectively to overwhelm the enemy. And I'm happy to say that when I look at what we're doing, I am impressed. But I also ask questions that are based on my combat experience. So when I see things, and like recently, I got a demonstration of some terrain evaluation tools that are being developed, and they were showing certain things, and I saw it differently, and I asked them, hey, well, what if you weren't trying to direct fire against the enemy? What if you were trying to figure out how the enemy can direct fire against you? Have we thought about how we can use these tools to do that? And seeing that different point of view, I think, is important from a research point of view. But some of the great things we're doing, for example, in our tactical geospatial information capabilities, or our TGIC program, we're developing these enhanced terrain processing tools that are reducing from hours to literally minutes the time it takes to do terrain analysis and route analysis and other geospatial requirements. And these are the things that I used to do on acetate overlays, and now they're being done in literally minutes instead of hours in an automated fashion. And in our functional area terrain evaluation program, we're delivering similar tools, but sort of with the geospatial analyst built into them. So someone who's a field artilleryman or an aviation planner can do an appropriate level of geospatial analysis to make sure they're doing effective planning. And another thing that I've learned from my experience that I hearken back to often is the essentiality of the geospatial, or the engineer and geospatial, and the intel relationship. These two separate functions are absolutely essential to one another, and they're both on their own very important, but together they're absolutely critical and essential to warfighting. And when I think about the things that I did back then that are being automated by capabilities developed inside the Geospatial Research Lab, I'm just amazed. Intelligence preparation of the battlefield, maneuver combined obstacle overlays, producing products together to close with and destroy the enemy. That is an essential function that we're fulfilling in the Geospatial Research Lab. And it really is inspiring to me to see the work that's being done, given my background and experience in the Army.
Absolutely. And I want to take this time to remind our audience, in case you've just joined us, I'm here today with Mr. Hibner, and we are talking about everything geospatial engineering. And so I know that you have questions, so be sure to put those questions in the comments, and we will get to those soon. And so for those who may not know, could you explain what geospatial engineering is and why it is so important? So you've been through some of it, talking about MDO and some of your experiences. So can you kind of explain to us what geospatial engineering is and why it is so important?
Sure, yeah. I'll start out by pointing out that geospatial in the engineer regiment is one of three pillars of the engineer regiment. And those pillars are combat engineering, general engineering, and geospatial engineering. And so it's, again, part of this critical three-legged stool for the engineer regiment. And I think it highlights the importance of that function that it's pointed out of one of just three of the essential things that we do inside the engineer regiment. So I'll start out by pointing out just a point of reference, and that is that geospatial really cuts across all the warfighting functions. And it starts at its foundation with just geospatial information. So geospatial information is basically anything that you might picture on a map, for example. The roads, the bridges, the terrain, the elevation data, all those things are geospatial foundational information that really are essential to conducting military operations, and I think for fairly obvious reasons. And then what we do is we make sure that that foundation is shareable, that it's viewable, that it can be used to produce the products that are required to be produced for our warfighters. And we do that by establishing and maintaining what we call the standard and shareable geospatial foundation. And so when you take that standard and shareable geospatial foundation and you combine that with intelligence, what you're doing at that point is you're creating geospatial intelligence. And as I mentioned earlier, that combination is absolutely essential. So now we're taking that foundational geospatial information about what's happening on the Earth, and we're combining it with information that we have about the enemy, where they are, what their disposition is, how many there are, where we think they're going to go. And we're putting those two things together into geospatial intelligence products, which are absolutely essential to all the warfighting functions. And again, emphasize again, it cuts across every warfighting function. It's an absolutely essential element of everything we do. So that importance just can't be overstated. Without the ability in time and space to converge combat capability against the enemy, combat forces literally cannot function.
And so recently, the Honorable Christine Wormuth, Secretary of the Army, has outlined what it would take to transform the Army, including rapidly sharing data and communicating with other services and coalition partners. How is GRL supporting the overall effort to shape the future of the Army?
Yeah, I think what I'll do for this is I'll start out by repeating some of the messages that I'm hearing from Army senior leaders on Army transformation, because I think it really sort of sets the stage for what we're doing. So the first thing that you hear a lot is pointing out the difference between transformation and modernization. And that difference is a pretty important difference. If we're really talking about transformation, we're talking about new, novel capabilities. So one that we could probably point out recently from what we're seeing in Ukraine is counter UAS capability. We're seeing a lot of new, novel capabilities emerging on how to counter UAS. Where modernization, you're really just improving an existing system. Now, there's a time and place for both, but the Secretary of the Army is talking about transformation. She uses that word very deliberately. And then the other thing that I'm hearing often is an emphasis that the Army's mission is to fight and win in close combat. And the underpinning for winning in close combat is command and control. And again, as mentioned earlier, you really can't do command and control without geospatial information and geospatial intelligence. And a third thing that I'm hearing is that the transformed Army must do mission command on the move from a tablet with a common operating picture and an intel common operating picture. So, sort of breaking the paradigm of the way we think we're going to operate when it comes to how we do mission command. There's 4 attributes, and I heard General George recently point out these 4 attributes for Army transformation. The first one is simplicity. So for simplicity, if you were to imagine, instead of having a phone with a bunch of apps on it to do a variety of different things, what if you had a new phone for every capability that your app does? So you would have one phone for banking, you would have one phone for phone calls, you'd have one phone for texting. Well, that sounds like it would be really inefficient, right? But unfortunately, a lot of the Army systems are kind of designed that way right now. And so we want to get away from that. We want to go to having just one phone with the apps on it that we need to function effectively. The second attribute is intuitiveness and learnability. So if you were to buy an iPad or a Galaxy smartphone, you'll know, well, you probably won't know that it doesn't come with instructions, right? There's no manual showing you how to use that technology. And the reason for that is that it's so intuitive now that you don't need it. You can go in and, using similar processes and using similar functionality, you can hand somebody a tablet or a phone that they've never seen before, and they can go in and really effectively use it. So that's what you want to do for Army systems in our Army transformation. The third attribute was low signature. So that means less people, fewer vehicles, no antenna farms, leveraging commercial networks, really trying to blend into our surroundings in ways that we've never thought of before. And here again, looking at what we're learning in Ukraine is that if there's a vehicle out there with a bunch of antennas on it, or there's a bunch of vehicles out there with an antenna farm around them, those vehicles don't survive very long. They don't survive very long at all. And so we know in the future we have to get away from that. So we have to transform and create capabilities that have a low signature. And then the fourth attribute he mentioned was constant iteration. So systems that are easily and constantly updated. So it doesn't take a monumental effort to do a version update on a system. That system can constantly be getting updates in real time, even on the battlefield. And so, all this is sort of in the backdrop of the Army of 2030 and pivoting to 2040, which we hear Army Futures Command and our Army senior leaders talk about quite often. And there are some challenges to consider. We have to do all of this while integrating fully autonomous and unmanned systems. So we're going to see these things in our formations, and they're going to have to operate very effectively in conjunction with warfighters, with people. And so we got to figure out how that's going to work. The future Army for autonomous vehicles isn't an army of autonomous vehicles. It's autonomous capability merged in with our formations. Then we're going to see smaller, more mobile tactical operations centers that can operate effectively on the move and that don't stay in one place for very long, and that we're going to be operating under persistent contact against a near-peer competitor in a DDIL environment, which is going to create all kinds of new challenges. So all these things, in my opinion, require some level of geospatial and geospatial intelligence to overcome. So what is GRL doing to get to the answer to your question? We've been participating in a series of focused excursions to showcase how we'll unlock transformational capabilities for the Army. AGC and GRL have both been participating in Army Futures Command's Project Convergence to help the Army achieve our goals for multi-domain operations and to integrate with the Joint All-Domain Command and Control System. We're working on advances in remote sensing technologies and the data that they'll collect. And that data is going to unlock a new understanding of terrain and how we can leverage terrain to create strategic and tactical advantages. We're developing more advanced geospatial systems that are moving from based in 2 dimensions to 3-dimensional based capabilities. And we're developing an understanding of how that will challenge our future systems. I mentioned TGIC before. Work being done in TGIC is being done in conjunction with the United Kingdom, but with the intent to expand that to other international partners. We're going to be involved in future mission command information systems development to make sure that our decision makers and leaders have intuitive map-based decision support tools with appropriate cross-domain solutions that promote sharing. And the last thing I'll talk about is the proliferation of sensors. So, this is something that we're seeing in Ukraine where there's an enormous amount of sensing capability available to both ourselves and our adversaries. And so if you look at it in the context of multi-domain operations, to understand sort of the world of the possible of sensors, if you kind of look at an X and Y axis, on the Y axis, you've got all the different domains. So from a geospatial perspective, it's probably space, aerial, unmanned aerial systems, terrestrial, subterranean, bathymetric. And then along the Y-axis, if you could imagine all the different types of sensing capabilities that are out there, like SAR, RF, LiDAR, electro-optical, the list goes on. And then you think about all the different data points where those two things come together. So for example, for one world terrain, you've got electro-optical combined with space. And so that creates this world of possibilities. If you think of it like a square, this world of possibilities for data that's going to be available on the future battlefield. But then we have to realize is that it's not just a square, because that's two-dimensional. Mm-hmm. It's actually a cube. So then you stretch that cube out from its face to encompass the entire depth of the battlefield in multi-domain operations. And now you've got sort of the entire universe of available data through sensors, from near targeting to deep targeting, and inside domains that aren't domains that we're very comfortable operating in. Things like space, for example, or the digital domain. And so that's world of possible sensing capability is really enormous on the future battlefield. And so what we want to do at AGC, and of course GRL is involved with this as well, is when the One World Terrain program transitions and it comes to AGC, we want to expand that world of possibility to encompass the entire cube. So One World Terrain would no longer just be space-based electro-optical capability. It would encompass that entire cube, and then truly it would fit the title that it has of One World Terrain. And so that's something we've been working aggressively on with several different PEOs, and of course this DCFT, where One World Terrain is inside AFC.
So we've talked a lot about your support to the warfighter, and I know that there is a patented GRL technology looks at transforming buoys along our nation's inland waterways in smart buoys, potentially creating a digital network that could transmit and share critical navigation information along river systems. What are other programs and projects focused on our nation's critical infrastructure components and networks?
Yeah, the digital buoys capability is really an interesting one. And, just for those that don't know, there are about 12,000 buoys in our inland waterways. And again, for those that don't know, the U.S. Army Corps of Engineers is responsible for maintaining the waterways, the inland waterways. And so these buoys essentially are the street signs and the stoplights of our inland waterways. So the traffic control mechanisms for more than $200 billion in annual commerce that travels over those waterways. And so we can tag and track those buoys as they drift, and the mesh network that is provided gives us communication capability back to the inland electronic navigation charts, which are maintained by the Army Geospatial Center on behalf of the Civil Works Business Intelligence Program. And as a side note too, we also maintain the National Inventory of Dams for SWIBI as well. But we estimate that the Digital Buoys program could save USACE and the Coast Guard, because it's a combined requirement between those two agencies, could save them more than $200 million in buoy maintenance and replacement costs if the system were fielded across all the inland waterways. And on top of that, they would improve maritime safety and enhance the system efficiency. But we are doing some other things when it comes to our nation's infrastructure. For example, we're working with CHL, where we've adapted our bleach and water generation work to tackle biofouling in wells. We're also leveraging our remote sensing capabilities so that they can be adapted in a plethora of ways to support tracking of critical attributes for our nation's infrastructure. And some of those proposed capabilities are 3D geospatial analysis tools for feature extraction, national infrastructure mapping and modeling tools, delivering more advanced remote sensing methods and capabilities to USACE divisions and districts. And so, I think when it comes to what we can do to support our critical infrastructure, remote sensing is going to have a huge role in the future.
Absolutely. So I want to remind our audience, if you have just joined us, we are here today with Mr. David Hibner, who is the director of both AGC and GRL. And we are now taking your questions. So if you have any questions that you would like to ask, just put them right there in the comments. So our first audience question is, in this evolution, how do you reduce the uncertainty that the use of technology entails, especially in critical fields such as the Army? So how do you reduce the uncertainty that the use of some of the technology entails, especially in critical fields in the Army?
Yeah, I think some of that goes back to some of the attributes that General George mentioned recently in a speech that I heard him give, where we want to make sure that what we're fielding is simple, that it's effective, that it can be constantly updated, that it has a low signature. I think simplicity has to be built into the systems to make sure that they're functioning and reliable. Again, kind of going back to my 113 example, not to say I didn't have the occasional maintenance issue with my 113, but for the most part, those systems were actually extremely reliable. And I think to the point the person who is making, reliability in those situations is absolutely critical to make sure that what we're delivering is doing whatever it is that it was designed to do reliably. And so I think reducing uncertainty can also be done through redundancy and making sure that there are no single points of failure in what we're developing. And then, also when you think about the effort to push to the tactical edge and the challenges that come along with that, and the fact that we might be doing that in a denied or degraded environment, we've got to have ways to fall back on systems by preloading them with information that we believe we're going to need if and when we enter a denied or degraded environment. So I think there's a number of different ways you can increase certainty when it comes to the evolution of geospatial technology, and those are some of the essential elements of accomplishing that.
So our next audience question is, can you speak a little bit about what's coming up for the geospatial enterprise at Army Geospatial Center?
Yeah, so this question is specific to AGC, or for
AGC?
Okay. Well, right now with the AG, we've got some challenges that we're working through. One of those challenges is the integration of 3D data, and that's something that we've been working on for a couple of years now. Now we've been delivering 3D data and 3D products for a couple decades now through our high resolution 3D program that we have at AGC and with our Buckeye program. But what we want to do is we want to leverage 3D data in ways that we haven't before. So as mentioned earlier, we published the 3D XORD on to the Army regarding the 3D data strategy, where we're asking for feedback on what that looks like and what requirements exist out there. And we're also going through an experimentation exercise called Project Terra, where We're testing some of those capabilities to see if they meet the requirements that are being described for 3D data. And we're also working through some challenges. Actually, to be perfectly honest, I think we're always working on some challenges with the Geospatial Workstation, but we're working on some challenges there for making sure that we've got an effective cross-domain solution and making sure that that system remains updated and upgraded and interoperable with other Army systems. So that's a couple things that are up and coming. But the biggest one in the future that I think that I would like to see integrated into the Army Geospatial Enterprise is the expanded vision for One World Terrain, where we bring that into the fold, and that One World Terrain essentially becomes the standard and shareable geospatial foundation for the Army Geospatial Enterprise.
Absolutely. Our next question kind of goes along with the previous one. Is the making of new generation of geospatial data engineering, for example, adding machine learning, real-time vision, and nature of the particular site at the time of operation coming, and how soon? So there's two parts of that question. So the first part is making of the new generation of geospatial data engineering and adding machine learning, real-time vision, and the nature of a particular site at the time of operation coming, and how soon?
Yeah, so that's a great question. And I think that really goes back to the challenges of multi-domain operations. The Army of 2030, and are we going to achieve the goals of Army 2030? And if we are, how are we going to achieve them? Because in multi-domain operations, it's not about being good enough. It's dominating in each and every of those domains. And again, like I mentioned earlier, we've got to have redundant communications. We've got to have an effective common operating picture with the focus on common. We need to win in a denied, degraded, intermittent, and latent environment. All these things have a geospatial flavor to them. So some of the things that we're doing in the Geospatial Research Lab we're enabling long-range standoff 3D using Geiger mode LiDAR and doing it faster with higher resolution and the ability to collect at higher altitudes and at extreme angles or far off nadir. We're working on 3D collection in interior spaces and tunnels. I mentioned earlier the functional area terrain evaluation capability, and TGIC I've mentioned a couple times now. Our network-enabled GeoInt and geospatial services, or NEGs, will automate and rapidly geo-register data, feature extraction, change detection, and visualization to enable rapid decision-making. So this is starting to get to what you're talking about, where we're automating those things and we're letting the system do the thinking for us so that we can save time and do it more effectively. We're working on the ability to integrate planning tools into multi-domain operations, including our JPS capability, our geospatial enabled operational design, our map-based mission planning tools, many of which are already transitioning to command post and computing environment. But again, getting to your specific question, we're also working with the Chief Digital and Artificial Intelligence Officer for DoD to advance these capabilities further by integrating artificial intelligence into them. So joint planning services and GEOD and map-based mission planning will leverage artificial intelligence in the future to do the geospatial functions faster and more efficiently in the future. And I think those are a pretty strong list of things we're doing to try to further automate and potentially leverage things like artificial intelligence into future capabilities.
And so the next question, the second part of that question, we know that the Army of 2030 is right around the corner. Is there a role for academics and the private sector to participate in accelerating this vital vision?
Yeah, I think there absolutely is. And in fact, I think we could benefit from more of that external perspective because, although I was sort of touting my internal perspective of how I see things based on my experience in combat, I think it's equally important to balance that against other perspectives. And I think academia can provide some really unique perspectives on how to achieve our goals for the Army of 2030, because it really is around the corner. And I think why you're seeing the Secretary of the Army and the Vice Chief of Staff of the Army and the Chief of Staff of the Army talk about the Army of 2030 so much is because I think there was this sensing that we were still designing the Army of 2030. So they made very clear, no, we're done designing the Army of 2030. We're delivering the Army of 2030. And we're designing the Army of 2040. And that urgency stems from the current geopolitical situation in the world, where we see a near-peer competitor that we may very well be going to war with. And in order to do that effectively, to make sure that we win that war, we need to make sure that we're meeting the requirements for the Army of 2030. So the window of opportunity to affect that is closing, but we're still figuring a lot of things out for the Army of 2030. Despite that shift in focus from Army Futures Command and senior leaders in the Army, there's still a lot that's being worked out in terms of the Army of 2030. And I think there's a lot of value that could be added from academic involvement.
And so I will make a short plug. If you are part of the academic community or private sector and you want to be part of this vital research, one of the best ways is to visit our ERDC Works site. So that's ERDCWERX.org. You could just Google it or go to the ERDC website with Business with Us, and you can find out all the information about partnering with ERDC so that we can deliver this vital message, this vital vision. So our next question is a great question because we know that we are recruiting, and so we want to be adding people to our ERDC family. What would a student major in to become a geospatial engineer?
That's a great question. Frankly, we need people from a lot of different career fields, especially in this data-centric future that we're all moving into. We're still going to need people who are experts in mapping and experts in geology and geospatial analytics. But equally important is going to be data scientists and people who are great at writing Python code and things like that. So I think the opportunity to work in the geospatial field is pretty wide based on the academic career fields that could, or the academic focus areas that could lead to a geospatial career field. I would say that especially in the future, so part of the challenge with this one world terrain capability that I've described, the future capability that we'd like to achieve in accomplishing that entire cube, that entire universe of data management, is that we have to do something effectively called content management. And so essentially that kind of gets to one of the core things that you do in geospatial, where you're collecting data, you're processing that data, you're turning it into products that are useful for warfighters, and you're delivering that data. So that content management capability is going to require an enormous amount of different skill sets to do it effectively. So, I think it's hard to name just a handful of academic focus areas that would lead to geospatial, because it really could be anything in the computer science area. It could be anything in the space area. It could be anything in geology and in geospatial area. I think the window of opportunity is pretty broad in terms of academic areas. And I'll tell you this too, is, we're almost always recruiting, and we're looking to grow our geospatial research lab. So if there's interest in being a part of that team, I would say reach out to us and let us know what's your academic background and what are some of your career objectives and goals, and let's see if there's a good fit for you somewhere in AGC or GRL.
And so if you have been inspired by Mr. Hibner, as I have, and you're like, I would love to work with him. I love this type of research they're doing, and you're a student out there. There's an easy way for you to connect with us. Again, it is our website, erdic.usace.army.mil, and you simply go to Careers with Us tab, and that is how you connect with us, and we can get you in touch with how to apply for a job at GRL. So that excellent advice. So our next question is, when we think of geospatial, we think of space. How closely do GRL and AGC work with other branches such as Space Force to win in space, an area that has become a very contested environment?
Yeah, I think there's an enormous opportunity to do more in space and with national level assets. And just sharing a recent personal experience, I was at a trek at Philmont Scout Ranch. I'm sure there's some people out there who are familiar with that. I was out there with my daughter and my son and a crew of scouts, and we were at a campsite one night, and we were kind of looking up at the stars, which is a great thing to do when you're out at Philmont. And you could literally see just racetracks of satellites flying overhead. It was absolutely incredible, and it just seemingly went on forever. So, amazingly, space is getting crowded, but that means that there's a lot of capability that's being sent up there, and we're doing it a little smarter than we did in the past, so that we're managing the debris that is created by sending that capability into space. But there's an enormous amount of capability up there, and it's only going to get bigger. But up to now, from AGC's perspective, we've really leveraged national level assets, mostly through the National Geospatial Intelligence Agency, NGA, the National Reconnaissance Office, our own Army Tactical Exploitation of National Capabilities Program, TENCAP. And we have had meetings with the U.S. Space Force, and we may even have a U.S. Space Force organization lease space in our building, which will be a great opportunity for creating a future partnership and maintaining that partnership. It's a very strong one. But what I'll say about space is that I really think we're just on the leading edge of the frontier of the possible for military operations that are space-based. And I think it was in January or February, I was at Fort Carson, and I met with a general from the Space Force. And the thing he pointed out, because we had all kinds of questions, of course, we wanted to know a lot. We wanted to see his org chart, all these things. He was kind of overwhelmed by that. And he said, hey, I want to point out that the Army has a 248-year head start on the Space Force. So we're standing up this capability. It's going to be a great capability, but we're figuring things out. And so to me, that meant that this is a great opportunity to sort of get in on the ground floor and have a strong partnership with the Space Force. And so that's why I was meeting with him. That's why we have meetings here inside the CUTE building on HEXA with Space Force organizations, is to build out that capability. But we really are building it out. It's sort of nascent in terms of what we're doing directly with the Space Force. Again, we've leveraged national level assets. We do that very effectively in the data and the products that are produced from those assets. But in reality, what we end up doing with One World Terrain is likely to be our first direct experience with a space-based asset. But we would like, again, to expand to that entire world of the possible, which would mean that, if you're looking at that X and Y axis for space, that would include, doing synthetic aperture radar from space. That would include electrical optical from space. We met with a company recently that is working on trying to do LiDAR from space. So we're moving into a world where space-based operations are improving and expanding. And some of the constellations that are being launched most recently by companies like Maxar and Raytheon are producing pretty good high-resolution data, about 25-centimeter resolution compared to what we've gotten in the past, which is 50 centimeter. which is great, but it's still far from what we get from Buckeye, which is about 5 centimeters. But we're seeing things moving in the right direction. And, with big companies like Maxar and Raytheon and Lockheed Martin launching constellations and in the pipelines to take the data they're collecting from those constellations and turn them into geospatial products, that competition is going to be good. I think it's going to be good for R&D, and it's going to be good for driving costs down in the long run, because if we're going to do content management on that entire universe of data to include what's coming from space, we're going to have to be pretty cost efficient to make sure that it's affordable. But again, I think the potential to do more in space is huge, and I think even as a nation, with briefings that I've had from NRO and NGA, we are going to see a further expansion of capability in space, and I think we're still really in the starting blocks.
So the next question actually piggybacks on some of what you were talking about with some of your industry partners. Could you share any success stories working with innovative startups? And if not, what role do you see for innovative startups?
I think innovative startups are critical to R&D, and I don't think I've ever turned away someone who wanted to come in and show us what they're working on and discover a way that we might be able to help each other. A recent example of that was this innovative startup that's trying to figure out how to do LiDAR from space. Now, that's a tall order, and I can tell you within GRL, we have some people who are really good with lasers, and they do a lot of LiDAR research, and they're kind of doubtfully tilting their heads and saying, well, it would be great, but there's all these challenges that they're going to have to overcome to do this effectively. But that doesn't mean we don't want to see them succeed. We do want to see them succeed. So, with that particular startup, we offer to have a continued conversation on this and continue to discuss these challenges that, based on our experience with LiDAR, we think they're going to have to overcome, and then sort of keeping track of how they're doing so that when that capability becomes closer to a capability that can be acquired for military purposes, that we're ready to do that, and that partnership will already exist. So that LiDAR company is a good, I think, really recent example of partnering with startups and trying to help them succeed and bring those technologies into the fold for military operations.
Absolutely. So, Mr. Hibner, we're going to wrap up. Do you have any closing thoughts as we end this ERDC Live?
Yeah, I think the last thing that I would like to say is that, I've talked about a lot of stuff, right? I've talked about a lot of things. I've talked about a lot of capabilities. And we've touched on this, but I really want to emphasize this, that it really is not about the stuff and the capabilities. It's about the people. It's about the people who are conducting the research, that are doing the critical thinking, that are overcoming these enormous challenges, that are building these partnerships with other organizations to make sure our programs succeed, that are people who are integrating with the other labs inside of ERDC to make sure that their programs are successful, to make sure that the research development areas in ERDC have the geospatial support that they need to be successful. It's really a pleasure and an honor to lead the people inside of the Geospatial Research Lab and the Army Geospatial Center. And I'll add to that ERDC as well. The things that are happening inside these organizations really are mind-blowing, and it's people who are doing this, really smart, dedicated professionals, scientists, engineers, and others who are dedicating their lives to making sure that we fight and win our nation's wars, and they're just doing an amazing job. So, just wanted to point out, a lot of things, a lot of capabilities out there, but behind all that neat stuff, it is a big group of people who are doing incredible things.
Thank you so much, Mr. Hibner. And thank you to our audience for attending today's ERDC Live. And be sure to tune in next month as we talk to Dr. Rebecca about paint technology. And so we will see you next month. Until then, find your joy. Thank you so much. That was amazing. We had so many people online.